Hello and welcome back. Today we're going to be looking at the AP Calculus exam, the 2015 test. And we're going to be starting with question number 1. Now question number 1 is a very popular question. It's been occurring on many AP tests recently. And it talks about rates of change. So let's go ahead and take a look at this. It says the rate at which rainwater flows into a drain pipe is modeled by the sinusoidal function, R of t, and it's giving us the rate in cubic feet per hour. So we got a unit right here, and we're looking at about, looks like what, 8 hours, 0 to 8 hours. Now the pipe is partially blocked, allowing water to drain out at the other end of the tape, at the other end of the pipe, modeled by this rate, d of t, in cubic feet per hour, again for the 8 hours. Now they tell us that there are 30 cubic feet of water at time t equals 0. Now right away this is our initial condition. So they're telling us that we have initially 30 cubic feet of water, which for me kind of says, okay, we're probably going to use the fundamental theorem to find the original amount. So let's go ahead and reread the question, take a look again. Now we see a key word here, hopefully, at the very beginning, the rate. Now, anytime we see the word rate, we should be thinking of the phrase that this is a derivative. So these are giving us derivatives, and along with the initial condition, kind of confirmed my suspicion that we're going to be using the fundamental theorem of calculus in just a few moments. All right, but let's go and take a look at part A. It asks, how many cubic feet of rainwater flow into the pipe during the 8 hours? Now, take a look. They give me the rate at which water is flowing in. So they give me the rate at which water is flowing in, but they want me to find how many cubic feet. They want a value. So to go from a rate to a value, we are going to have to integrate this one. So to get the amount, we would integrate our rate, R of t dt, from 0 to 8. Now you can leave it as R of t dt if you want to. You don't have to write in the equation. But we are going to have to get the answer right here. So let's just look at real quickly the units and what this is going to give us. R of t we know is in cubic feet per hour. Cubic feet per hour. The time dt is in hours. So yeah, this is going to give us my unit that I want, cubic feet. So I know my integral will give me the right answer here. When I type this in my calculator, and remember this is a calculator question, question numbers 1 and 2 are calculator questions, press enter. I'm going to go, and I'm using the TI Inspire CAS. If you use the CX, it's the same thing, just a few differences. For example, I'm going to use menu 3 for the integral. I think on the CX it would just be 2, so I'm going to use 3, from 0 to 8, and I just type in our function, 20 sine. Make sure you are in radian mode. Now I'm going to use x squared, even though they use t. Whoops, I'm in cap lock. Let me get rid of that. X squared divided by 35. And don't forget your differential, the dx right there. Press enter, and we get 76.570. You can go 5704 if you want to. The AP is going to round, it's going to cap it at the third decimal place. Round it there. So we get 76.570, and we already know that that's going to be cubic feet, so we might as well go ahead and put our unit there. So how many points would this be worth right here? You would get 1 for your integrand, and you would get 1 for your final answer. So this question would be worth 2 points on the AP. Part B, it asks, is the amount of water in the pipe increasing or decreasing? Now this is a tougher question. Every AP question has one little tough part. This is it. This is a tough one right here. And this is the one that's very popular now. It says, is the amount of water increasing or decreasing? It's the phrase increasing and decreasing that we need to really look at. Increasing and decreasing is comparing the rates. I need to compare the rates. In other words, this is a derivative question. So we're talking about water. Water is flowing in and water is flowing out. So what we want to see is if the water flowing in is more than or less than the water flowing out. And we can compare the rates to do that. There's a lot of different ways to do this. I subtract them. That's my way of doing this one. For example, I would say let's take the rate of the water going in. Whoops. I would take the rate of the water going in minus the rate of the water going out at t equals 3. And this is what I would do at t equals 3. So we would get r of 3 minus the rate going out, that's d, minus d of 3. And again, they don't want you to do this by hand. You can use the calculator for it, but we're just going to type all of this in here. And this honestly takes longer to type in than it does to understand the calculus. So I got to type all this in. 20 sine 3 squared, because I'm plugging t, so that's 9 divided by 35, minus, and I'm going to type in here, negative, minus, I should use parentheses here, negative 0.04 times 3 cubed, which is 27, so times 27, plus 0.4 times 3 squared is 9, and then that becomes plus 0.96 times just 3. And I press enter, make sure everything's typed in correctly here. 20 sine 9 over 35 minus 0.04 times 3 cubed, which is 27, plus 0.4 times 9 times 0.96 times 3. You want to double check your calculator work, otherwise you'll never know if you really get it wrong. It's a really tricky thing about the calculator. When you press enter, I get this negative 0.314. Now, what does that mean? Well, this is less than 0. So what does it mean that this is less than 0 right here? Well, this is my rate in minus my rate out. It means that my rate out is greater than my rate going in. So it's decreasing. So we can say, therefore, since, and we can say that r of 3 minus d of 3 is less than 0. Just use your calculus skills. We can conclude, or we can say that the amount of water is decreasing. Watch, let's go chemistry. The amount of H2O is decreasing at t equals 3 hours, right there. And there's our answer. So let's talk about how many points this would be worth. Setting up your information right here, just setting up this is +1. Now you could have done it other ways. You could have just compared them. And over here, your final answer with your justification is also 1 point. So far we're at 4 points. That's a good solid 3 on the AP almost. So pretty good. All right. So for part C, now it asks, at what time between 0 and 8 is the amount of water in the pipe at a minimum? Ooh, there's our phrase, a minimum value right there. Now, once we see something like this, man, I'm starting to think candidates test. We haven't seen this one in a while, so let's think candidates test. Well, we want the amount of water in the pipe, so to get candidates test, one, we need our endpoints, and we're given those. T is 0, T is 8. We also need our critical numbers, the amount of water in the tank. So that is just basically where R of t minus D of t equals 0. Not just R of t equals 0, but that rate equals 0. Remember, this is the rate of the amount. This derivative, or this equation right here, represents the rate at which the water is changing. Right here. So I want that R of t minus D of t equals to 0. So I can find those by using my calculator, and I'm going to graph these actually. I'm going to graph this time. So some people use NSOLVE. I'm just going to graph the equations. Where does 20 sine, what is that, x squared, remember I'm going to use x squared divided by 35, minus, let's see here, this negative, so my negative 0.04 x squared plus 0.4, oops, that should be x cubed, excuse me, x cubed plus 0.4 x squared plus 0.96x. There we go. I press enter, and I'm looking for where that equals 0, And I'm only going up to 8, so I don't need this number right here. It's way too far out. I only need this part. I'm going to get rid of my label here. So let me see here. Get rid of my label. Escape. Delete it. And so we're looking for just this intersection point. It looks like it meets at 0, but I already have 0. So I know 0 is one of my choices here. To get the next one, I'm going to find this point right here. Menu. Analyze graph. Look at that intersection. Enter, I guess. Okay, escape. Menu, not intersection. Oh, that's silly. I'm looking for the 0 there, not the intersection. Sorry about that. So, looking over here, there we go. Scroll over. I press enter. Now, the AP likes a few more decimal places, so if you're on the Inspire Castle to see activity just over the X value, just press enter there and press the plus sign. It'll take it out a couple more decimal places. So we're going to use 3.272, rounded up there. So those are my choices. Now we're not done, but we're not done because now we got to plug it into our function r of t. So, and this is the tricky part right here. We have t, we have our endpoints 0 and 8, and we have our one critical number 3.272. But now we got to plug into our function the amount of water. So let's find out how we get the amount of water in the tank at the time. Well, the first thing I would do is I would have to integrate the r of t minus d of t from 0 to 8, or 0 to t, I guess, just keep it generic. R of t minus d of t dt. But you got to be careful. Now this is going to give me the amount of water that's increasing over any given time period. But you got to remember, initially we had how much water in there? 30 cubic feet. So I have to add 30 to this one. This is a tough one right here. The integral 0 to t, r of t minus d of t dt plus 30. And I'm just going to type all these in. Now 0 to 0, that's easy. That's just going to be 0. So I'm going to use my calculator again to write out my integral here. Go to my home screen, homie. And I'm going to use menu 4, use my integral again, 0. Now my first t I'm going to use is this 3.272, and I'm going to type in my equation, r of t minus d of t. Alright, so that's going to be our 20 sine of x squared divided by 35, go out of there, minus, remember, parentheses again, I'm going to type all of this in again. That was this negative 0.04 x to the third. That's going to be then plus 0.4 x squared, and then plus 0.96 x. Don't forget your differential. X, I press enter, and I get we get after a quick edit, I realized I typed in 0.04 instead of 0.4 x squared, and we get this negative 2.0354. But don't forget, we have to add 30. Remember, always check what you type in your calculator. I didn't do that, so I messed up there. So plus 30 here, and we get 27.965. And I just do the same thing with 8. Now I don't have to be too fancy. I can just go up here and just change scrolling over instead of typing the whole thing again. Let's see, will this work? Oh, there we go. I can just type in 0 to 8 now. And again, I have to add 30, and we get 48.544. So the question is, at what time is water at a maximum? Well, there's my maximum value. So we can say the water is at a maximum at t equals 8 hours. Alright, this is a lot of work. That's a tough one right there. So definitely take a look at this one again. What you're going to get, you can get a point for here, you can get a point for checking your candidates test, and you get a point for your answer right there. Alright, the last one for part D. Now look, this is a tough question right there. So go back and look over it again. This is a tough part right there. But nothing you guys can't do. Part D says the water can hold 50 cubic feet of water before overflowing. for t is greater than 8. Water continues to flow in and out of the pipe at the given rate until the pipe begins to overflow. Right, but do not solve, my favorite phrase in all of mathematics, do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. Well, we know from part C to get the amount of water, we would use the equation, the integral 0 to t, r of t minus d of t dt plus 30. Remember, this is the amount of water increasing between 0 and time t. The 30 is our initial condition. I want this to just equal the overflow. When will this equal the overflow? So we want to know when this equals 50, the overflow right there. Now, of course, they say use time w, so that's easy to fix. I'm just going to fix this right here. Whoops, not my integral. There we used t there originally. I am just going to change this to a w. So 0 to w, r of t minus d of t dt plus 30 equals 50. And this will solve for us right there. Now another way I could write it this way. I can just use my FTC, which says the integral from 0 to w will equal of r of t minus d of t will equal, remember this, f of w minus f of 0. Well, f of w we know is what's going to be 50, and f of 0, that's my initial amount, 30. So I can write it this way as well. All right, and this question is worth 2 points. You get 1 point for just your integral, and then you get 1 point for the entire equation right there. So 2 points. I hope you enjoyed this video. Go on to question number 2, and we'll take a look at that one. Bye-bye.